We're going to talk about another fraction that we can divide this up into. You know that if we wrap pi units, we always start here, and we're going to end up right at -1, 0. Well, instead of going all the way around, what I'm going to choose to do now is pi divided by 3. So I'm only going to go a third of the way around here, which is going to put me somewhere probably over here. Now, the one thing I know is that when I went pi units around, so an arc length, if pi is the arc length, then I can also say that I had rotated 180 degrees. So on the unit circle, an arc length of pi inches or feet or whatever you want to call it is equal to rotating 180 degrees. Well, if that's the case, then pi over 3, if this is my arc length, then that's going to convert to 60 degrees. And we could use the arc length formula for that, right? Arc length is always going to be theta over 360 times 2 pi r. So I could justify this. An arc length of pi over 3 means that we're going to have theta over 360 times 2 pi, and the radius is 1. And let's see, I can divide both sides by pi. I can multiply both sides by 360, which is going to give me 120 equals 2 pi. So, 2 theta. So then theta is 60 degrees. Well, that's very convenient, because if I have pi over 3 radians, right, this is pi over 3, and I'm looking for the coordinates of this point, I need to go over and I need to go up. So every time I plot a point, I go over and I up and I go up and I carve out a right angle. And what I know is that this, which we're going to call a central angle, if you remember your geometry, is 60 degrees. And if this is 60 degrees, then this is 30 degrees. And the one thing we know about this triangle is that the hypotenuse has length 1, because this is a unit circle. So if the hypotenuse is 1, then the side opposite 30 degrees is going to be 1/2, and the side opposite 60 degrees is going to be this thing times square root of 3, which is square root of 3 over 2. So wrapping pi over 3 will leave me at the ordered pair 1/2 and square root of 3 over 2. If I was going to wrap 2 pi over 3, again, there are a number of ways to figure out what I could do over here. But I like to think of this as wrapping 2 pi over 3 is pi over 3, pi over 3. I know this point would put me at 3 pi over 3, so I know that what I am lacking to flip all the way over is another arc length of pi over 3. And if this arc length is pi over 3, then this angle, which in fact is important to me, is 60 degrees. And the reason that this is important to me is because when I go to plot a point, I go back and up. So there's my right triangle. And then this is 30 degrees, this is 1, we have 1/2, we have root 3 over 2. So wrapping 2 pi over 3 is going to put me at -1/2 and root 3 over 2. If I was going to wrap 4 pi over 3, I'm skipping 3 pi over 3 because I know that's going to reduce to pi. 4 pi over 3, I'm considering the fact that I'm mapping off an arc length that is pi over 3 past this point. So that, again, this is a 60-degree angle. The hypotenuse is still 1. So wrapping 4 pi over 3 puts me at the ordered pair -1/2, negative root 3 over 2. And by similar reasoning, if I was going to wrap 5 pi over 3, that's going to put me right down here. Pi over 3 shy of 6 pi over 3, which would bring me all the way around. So 5 pi over 3 is always going to leave me with the rectangular coordinates +1/2 and negative root 3 over 2. So in short, anytime you have a multiple of pi over 3 that is not going to reduce to 3 pi over 3 or 6 pi over 3, you know that we're somehow going to have some combination of 1/2 and root 3 over 2. And this fact you need to memorize.